Hello everyone. So today we are back again with a new lecture on the topic methods to reduce stress concentration. Okay, so moving on to the topic, let us discuss what are the methods to reduce the stress concentration. Okay, so here it is. Effect of stress concentration cannot be completely eliminated, but its effect can be reduced by slightly altering the geometry of the components. Flow analogy is helpful in understanding how a particular discontinuity affects the stress distribution around it and how its effect can be reduced. Okay. So in the next slide we will see a figure which shows the stress distribution in an axially loaded plate, which is similar to the velocity distribution in fluid flow in a channel. Okay, so for a channel having uniform cross section, velocities are uniform and streamlines are equally spaced. If the cross section of the channel is suddenly reduced, velocity increases to maintain same flow and the streamlines become narrower. Similarly, with reduction in cross section, to transmit same force, the stress lines come closer. Location where the cross section changes, stress lines bend as the streamlines do. Okay, so sudden change in the cross section leads to very sharp bending of stress lines, which results in stress concentration. Okay, so sudden changes in cross section leads to very sharp bending of stress lines that results in stress concentration. Okay, therefore by avoiding severe bending of the stress lines, effect of stress concentration can be reduced. So in the next slide we will see a figure that shows certain methods to reduce stress concentration. Okay, so here in this figure you have seen the stress distributions, that is the flow analogy. Okay, so here in the next figure you have seen this is the pour. Okay, so here you have seen it is the poor form, it is the B, that is the good form. Okay, it is a good form. C, it is the preferred form. Okay, it is the preferred form. And D is the preferred, another one. Okay, preferred one. Okay, so it is the stress distributions flow analogy where you have seen in the figure A it is the poor form, figure B it is the good form, figure C it is the preferred one, and D also a preferred one. Okay, next here in this figure there are various methods to reduce stress concentration are being depicted here. So in this first figure, that is poor, okay, here bending moment are being acting here. Okay, in this way you have seen the arrow marks, the bending moment are being acted upon. Okay, so here P force is being acted upon both sides. Okay, both sides. Tensile force is being acted upon with this hole inside, and after that this pour form comes out to be like this. Okay, so this is how the stress concentration are being reduced. Okay, next you can see this is the good form. Okay, here also the bending moment is acting upon here M. Okay, so next is the preferred form. Okay, so preferred form also the bending moment are being acted upon, which here you can see this is the preferred form of stress concentration factor. Okay, so it is the good form, and here you can see it is the preferred form. Okay, so these are the methods to reduce the stress concentration. Okay, So with this we have come to the end of this topic, that is methods to reduce stress concentration. Thank you everyone.